solve this compound inequality, we know that this is an OR inequality because the problem explicitly says OR between the two inequalities. So to find the solutions for this compound inequality, we solve for x for each inequality. So for the first inequality, I like to move the variable to the left side. So 3x is already on the left side, so 3x stays positive. Is less than, and then constants on the right side. So I need to move -5 to the right. So -5 becomes +5, and you bring down the -23. So therefore, 3x is less than -18, and divide both sides by 3, so x is less than -6. And to graph this solution, since x does not include the -6, you have to use an open circle, and you shade on the left side of this line. And now to solve for the second equation, I'm going to do the same thing. So I'm going to move 3x to the left side, so that will become -3x less than or equal to, so move the -14 to the right side, so that will become +14 and bring down the -5. So now we have 3x is less than or equal to 9 and divided by -3. So because I divided by negative number, I have to change my inequality sign. So instead of x is less than or equal to, it will become x is greater than or equal to -3. And so to graph this solution, since x can equal to -3, so on -3, I'm going to use a closed circle. And because it's greater than, you shade on the right side of this line. And the solution for an OR inequality, they never overlap because all we want is either condition to be true, not both of them. And you can also write the solution for this inequality as in interval notation. So on the left side, it's going to be -infinity, and on the right side, it's going to be +infinity. So the solution for this compound inequality in an interval notation is you start at -infinity, which you always use parentheses, and it stops at -6. So because we have an open circle and -6, you also use parentheses. Or, and then it starts here again at -3 with a closed circle, so I have to use a bracket. So from -3 to +infinity. And that's the solution for this compound OR inequality.